All right, this is Algebra 1B Part 1. Algebra 1B Part 1, Unit 2, Lesson 8. We're going to be working with radicals and radicands and rational exponents and working with expressions that contain these. These are skills that you're going to need to use to solve equations later on. I hope to present a couple of ways to look at these. These are examples given in the lesson, but I'm going to solve them the way they did in the lesson and explain their method, but I will also show you some alternative ways to look at it as well. First one, square root 3 times square root 3. Okay? One of the ways we can look at this is we can express these with rational exponents. 3 to the 1/2 times 3 to the 1/2. And then we can use the product of powers rule, which says if you multiply the same base with exponents, you add the exponents. 3 to the 1/2 plus 1/2. 1/2 plus 1/2, you have a common denominator already. You can do crisscross across, but they have a common denominator already. So 1 plus 1 is 2, or 2/2, which is 1. And anything to the 1 power is itself. So this is just 3. Okay. Like I told you at the beginning, I'm going to do it an alternative way too. Square root 3 times square root 3, they both have the same radical. And so the radical actually can be expanded over to combine the 3 times 3. Square root of 3 times 3 is square root of 9, and the square root of 9 is 3. Okay. So when you have like radicals in multiplication, you can expand the radical over the product. The product of two radicals is the radical of the product. That's one way to say it. Okay, but you got to make sure the index is the same. These are both index 2. We didn't write the index 2, but this is the square root. If the indexes don't match, you can't do that. All right. So next example. Okay, cube root 64 over cube root of 8. Now you might think, oh, here's radicals that match again, and that rule does apply actually, and I'll go back and do that, and I think you'll see it's much easier. But here's the way the lesson presented it. This is 64 to the 1/3 over 8 to the 1/3, and we can get like bases if we recognize that 64 is 8 squared. 8 times 8 is 64. So this is 8 squared to the 1/3 over 8 to the 1/3. Okay? Use the power of powers rule. 8 to the 2 times 1/3 is 8 to the 2/3 over 8 to the 1/3. Now we have the quotient of powers rule. This is 8 to the 2/3 minus 1/3. 2/3 minus 1/3, they have a common denominator already, is 8 to the 1/3. And the cube root of 8, what times itself times itself times itself again, is 8. And the answer is 2, because 2 times 2 times 2 equals 8. Okay? All right, so that's the way taught in the lesson. Now let me do it the alternative way as well. Since they both have a cube root, the index is the same, we can extend the cube root over the quotient, 64 divided by 8. And 64 divided by 8 is 8. And the cube root of 8, or what times itself times itself times itself again, is 8, and the answer is 2. I'm sorry, yeah, the answer is 2. What did I do over there? You're probably screaming at the screen saying, hey, I said 2, but I wrote 8. Let's just cross it out and put 2. It's 2. Okay. All right. So there's more than one way to do these. So just be aware of that. All right. Next one. Notice this one, the indexes don't match. So the trick I gave you doesn't work. We have a square root. The index is assumed to be 2 if it's not written. And a 4th root. Okay. And so I'm going to give you an alternative way to do this as well, but here's the way it's presented in the lesson. This is 9 to the 1/2 over 81 to the 1/4. And noticing that 81 is 9 squared, So this is 9 squared to the 1/4 under 9 to the 1/2. Okay, using the power of powers rule, this is 9 to the 1/2 over 9 to the 2/4, which is 1/2, reduces to 1/2. I can use the quotient rule, or I can just notice that anything over itself is 1. We can say it's 1 right now, but here's the way the lesson did it. They did 9 to the 1/2 minus 1/2. 1/2 minus 1/2 is 0. 9 to the 0 is 1. Okay? That's not the way I would choose necessarily to simplify this if I were given this problem in the, just on sight. I would say the square root of 9 is 3, right? And the 4th root of 81 is 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So the 4th root of 81 is 3. And 3 divided by 3 is 1. That's actually the way I would do it rather than going through all these gymnastics. But the power rules can be useful. The reason we're emphasizing the power rules is not necessarily so you can simplify expressions with numbers like this, but so that you can simplify expressions with variables, which is something we're going to get into later. So it is important that you know how to manipulate things like this. Okay? All right, time. All right, 16 to the negative 1/2. 16 to the negative 1/2. We're going to apply the negative exponent rule, which says this is 1 over 16 to the 1/2. The way I remember it is this. If you have a negative exponent, the rule is you can take the base and the exponent across the fraction bar. If it's on the bottom, you can bring it up. If it's on the top, you can bring it down. If there is no fraction bar, the fraction bar is below it. So this is simply 1 over 16 to the 1/2. Okay? Now, I think the lesson has you rewrite this as square root 16. Okay? Or you can just realize that 16 to the 1/2 is the square root of 16. And what number times itself makes 16? And the answer is 4 times 4 is 16. So this is 1/4. 1/4. Okay? All right. And one more example. This lesson's chock full of examples. Okay? They go through an expression, a series of situations where they give you equations and ask whether the equation is true or false. Really what that amounts to is simplifying the left side and the right side separately to see if they match. Okay? As long as you get an equivalent, these are equivalent statements or equivalent expressions if the equation holds true, if the left side simplifies to the right side. All right? So 5 to the 2 over 5 to the 1. That's 5. And by the way, you can think of that as 5 times 5 over 5, and one of the 5's cancel, leaving 5 on the left. That's one good way to think of it. The lesson had you use the quotient rule. 5 to the 2 over 5 to the 1 is 5 to the 2 minus 1, which is 5 to the 1, which is 5. Okay. 25 to the 1/2 is the square root of 25. What times itself is 25? The answer is 5. So the square root of 25 is 5. And this checks out. The left side matches the right side, so the expression, the equation at the beginning is true. And 5 squared over 5 to the 1 and 25 to the 1/2 are both equivalent expressions. All right, so hopefully that helps. How's that for getting through something really quick, a whole list of examples fairly quickly?